Electronegativity Part 1 video, we discussed the meaning of electronegativity and polarity. And we did the difference in electronegativity and electron affinity. In Part 2, we discussed the factors controlling the electronegativity, atomic size, and closeness to the noble gases in the periodic table. These two factors are discussed in Part 2. In Part 3, we did the range of electronegativity on Pauling scale. Which element has the highest value of electronegativity and which element has the lowest value of electronegativity with reasons. Based on the difference in electronegativity, we also identified different types of chemical bonds, polar bonds, non-polar bonds, and ionic bonds. This is one of the most frequently asked questions in different types of examinations. In electronegativity part 4, following topics are covered with examples and practice problems, variation of electronegativity with hybridization of atoms, with oxidation numbers, with formal charges, and understanding of movement of electrons during resonance and chemical reactions due to difference in electronegativity. In electronegativity part 5, we will understand how electronegativity and induction and dipole moments are related to each other. We will use electrostatic potential maps to know which part of the molecule has high electron density, production of dipole moment, and based on these concepts, we'll do practice problems and a quiz. Induction and bond dipole indicates the direction in which electron density moves due to difference in electronegativity. These are very important terms which we need to understand so that we can explain many physical and chemical properties, including mechanisms in organic reactions. For example, in case of carbon-oxygen bond, carbon electronegativity is 2.5 and oxygen is 3.0. The difference in electronegativity will push electron pair more on the oxygen because it has more tendency to pull the shared pair of electrons on itself. Due to this, oxygen will acquire partial negative and carbon will acquire a partial positive charge. This withdrawal of electron density in the direction of oxygen due to difference in electronegativity is called as induction. And the separation of these two charges, plus and minus, is called as the bond dipole. So this chemical bond, which has a charge separation, has a bond dipole also. A bond dipole is represented by an arrow with a tail. The tip of the arrow is in the direction of partial negative charge and the tail of the arrow is in the direction of partial positive charge. Let's take another molecule, formaldehyde. In formaldehyde, oxygen is more electronegative than carbon. So carbon-oxygen bond has a polarity here. Oxygen has a partial negative charge and carbon has a partial positive charge. And the bond dipole is represented by an arrow. The tip of the arrow is in the direction of negative charge or oxygen atom. And tail of the arrow is in the direction of positive charge or carbon atom. Electrostatic potential maps are used to represent electronic charge distribution in a three-dimensional molecule. It helps in visualizing which atom of the molecule has more electron density and more electron rich and which atom in the molecule is electron deficient. This in turn helps in predicting the mechanism and how the molecules are going to interact with each other during chemical reactions. More negative is represented by red color and more positive is represented by blue color. Now in this molecule of chloromethane, chlorine is more electronegative than carbon. So you can see there is more electron density on the chlorine atom, which is represented by red color, and less electron density on the carbon atom is represented by blue color. The difference in electronegativity can be used to predict the direction of the bond dipoles. In this question, we are going to predict the direction of the bond dipoles based on the difference in electronegativity. Chlorine is more electronegative than carbon because chlorine is more closer to the noble gases and is more nonmetallic than carbon. So there is a partial negative on the chlorine and a partial positive on the carbon. So a dipole will be represented by an arrow. Of the arrow is in the direction of chlorine and tail of the arrow is in the direction of less electronegative carbon atom. In case of carbon and oxygen, oxygen is more electronegative than carbon because oxygen is smaller in size than carbon. So there is a partial negative on the oxygen, a partial positive on the carbon, and the dipole will be represented by an arrow. Tip of the arrow is in the direction of more negative oxygen and tail is in the direction of more positively charged carbon atom. In carbon nitrogen, nitrogen is smaller than carbon. Nitrogen is more electronegative than carbon. So there is a partial negative on the nitrogen, a partial positive on the carbon. And it is again represented by an arrow with a tail. Tip of the arrow in the direction of more electronegative nitrogen atom and tail of the arrow is in the direction of less electronegative carbon atom. Similarly, carbon and sulfur bond. Sulfur is more closer to the noble gases, so sulfur is considered to be more electronegative than carbon. There is a partial negative charge on the sulfur and a partial positive charge on the carbon. The bond dipole is represented by an arrow. Tail of the arrow is pointing in the direction of less electronegative carbon and tip pointing in the direction of more electronegative sulfur atom. Next is carbon bonded with boron. Boron is less electronegative than carbon because it is bigger in size than carbon. So there is a partial negative on the carbon and a partial positive on the boron. Now this time the tip of the arrow is in the direction of carbon and tail is in the direction of the boron. The difference in electronegativity to understand a chemical reaction. OH minus is very rich in electron density. Here oxygen has 3 lone pairs on it with a formal negative charge. So this OH minus can attack only on the carbon which is most electron deficient. And the carbon which is bonded to very electronegative atom is going to be most electron deficient. If we compare the electronegativities of the atoms present in the given organic compound, oxygen and chlorine are the most electronegative atoms. Hydrogen is the least electronegative atom. Carbon-hydrogen bond is the least polar bond. It means wherever chlorine and oxygen are present, that particular bond is going to be polar in nature. Chlorine with partial negative and carbon with partial positive charge. So here, oxygen with partial negative and carbon with partial positive. So OH minus is interested only on the carbon atoms which are electron deficient or with partial positive charge. So OH minus will attack either on the carbon bonded to chlorine or on the carbon bonded to oxygen. Difference in electronegativity can be used to show the direction of flow of the electrons in the resonance or in the mechanisms. Before starting answering these questions, let's review two basic rules of the resonance. During resonance, you can move only pi electron density and lone pairs. You cannot break a sigma bond or sigma bond cannot move. It means that we cannot move an atom, but we can move a lone pair. We can move this lone pair, we can move this multiple bond, we can move this multiple bond into lone pair, and we can move this multiple bond into another multiple bond. Now we are ready to answer some questions. We have to see that in which direction the lone pairs are going to move. These are the lone pairs which are going to participate in resonance, and they will move in the direction of more electronegative or electron hungry atom. Right now, this carbon is electron deficient and it has only 6 electrons around it, so its octet is not completed. This makes this carbon very electronegative. So the lone pairs of the nitrogen will move in the direction of carbon, which helps in completing the octet of the carbon. Let us check example 2. Here this nitrogen has a formal positive charge on it, but its octet is completed. It means it has 8 electrons in its outermost shell. A nitrogen cannot move more than 8 electrons. So the negative charge of carbon will move in the direction of more electronegative nitrogen, making a pi bond, but at the same time, the pi bond between nitrogen-nitrogen bond will move as a lone pair on the adjacent nitrogen atom. In this structure, carbon-oxygen bond, oxygen is more electronegative than carbon, so this pi electron density will move in the direction of oxygen as lone pairs. In this molecule, this carbon is positively charged and is electron deficient also. It has only 6 electrons around it. So this pi bond will move on the positively charged carbon to satisfy its octet. So that's how the electron density shifts from one atom to another atom for satisfying the octet or the charges. Thank you for watching this video in Electronegativity Part 5. We understood how electronegativity, induction, and dipole moment are related to each other. Use of electrostatic potential map to know which part of the molecule has high electron density. Prediction of dipole moment based on concepts, some practice problems, and a quiz. If you want to practice more questions on the same concept, please click on the link given below. You are most welcome to ask your doubts or questions in the comment section of this video. In this electronegativity series, which is covered in 5 parts, Part 1 is dealing with introductory part of the electronegativity and meaning of the polarity of bonds. Part 2 is dealing with variation of electronegativity with atomic size and closeness to the noble gases in the periodic table. Part 3 is dealing with the difference in electronegativity and based on that identification of chemical bonds as polar bonds, non-polar bonds and ionic bonds. Part 4 is dealing with variation of electronegativity with hybridization, oxidation number and formal charges. Part 5 basically is helping us in understanding the induction and bond dipoles and how the difference in electronegativity can be used to understand resonance and chemical reactions. In all the videos, we have done plenty of practice examples and we did some questions also together. And for every concept, there is a quiz on my blog. Links are provided in all videos. If you have any doubt or if you have any questions, you can ask in the comment section of this video or you can ask in the comment section of the blog. This series of electronegativity helps in understanding the basic mechanisms, the basic reasoning behind many chemical reactions. Links to notes and questions have been provided in the description below. Please like, share and subscribe and do not forget to click on the bell icon to turn on notification.